Hello everyone, this is Ms. Sarah. I'm back with my next lesson. So we are still on 11-2. So few more examples on derivative, but this is not just normal derivative. So I'll be teaching you guys, we're going to be learning about implicit derivative. Okay, so implicit derivative is the one where you see x and y terms got mixed up, and at the end we solve for dy over dx. So I'll show you a few examples on that. So first one is, and don't forget to have those rules handy, because you always need those derivative rules. In order to apply those, you have to have those handy, okay? All right, this is my first example. I have 10 times x times y, and it's equal to cotangent x and y. Okay, normally we just take the derivative of the right hand side if the equation is already equal to y, right? And x and y is like two different sides. This one where you see x and y both mixed up on both sides, so basically we just take derivative on both sides. So this one here, I'll start off with left hand side. If I take derivative, you can pull out the constant if you wanted, just to make it easier, and multiply at the end. You could do that. So I'm just going to factor out this 10. This is x getting multiplied by y, which is product rule, so x stays the same. Derivative of y would be 1, but since it's y term, it's dy over dx. So it's plus, now the second term, derivative of the first one, I have 1. Okay, I'm done with first part, or the left side. Other side, it's cotangent of this angle. So please keep in mind, for the first step, I don't care if it's y or x term. First thing, you gotta take the derivative of the entire trig function. It's cotangent of something. What is that? So derivative of cotangent of some angle is negative. It's cosecant square of that angle. Now, when it comes to taking derivative of the inside, that's where we're going to put dy over dx. So since inside the parentheses, it's x times y, so it means there would be another product rule, which is going to be similar as the first one. So I'm going to have x, 1, dy over dx, plus y, and it's 1. Here you go. Now I'm done taking derivative. Rest is just simplifying this big equation. So try isolating dy's, or we'll just put dy terms on one side, and the rest of the stuff we'll move it to the other side. So if I distribute this 10 here, this term would be 10x dy over dx, and I have 10y. On the other side, I would distribute this cosecant, negative cosecant xy, to both of these terms inside the bracket. So once I distribute, it's going to be, I can just rewrite it. I'll just put, hold on, I'll cross this out. So I would distribute that, so I would put x. Don't forget, I can now multiply this x with the angle x. Those are two different things. But instead, I would put x outside, so it's negative, and it's cosecant square x and y, and it's dy term. That's going to be my first term after distributing cosecant square. For the second part, again, I need to distribute the negative, so it's going to be negative there's a y, so there would be y, and it's cosecant square, and it's x and y. I hope you understand this part. Now, time to put dy's on one side and move rest of the stuff to the other side. So if I move this dy to this side, and I would take this term to this side. Okay. So, and I'm just going to skip a step here. So I'm already going to factor out dy dx. So if I factor out dy over dx, so I would have dx from this piece here. Once I move this term to the other side, isn't it, that would become positive. So it's going to be plus x cosecant square xy, and here you go, I already factored out dy dx. On the other side, it's going to be negative 10y minus y cosecant square x and y. All right, almost there. Last step. I would divide this side by this big expression, 10x x cosecant square xy. So I'll try simplifying more if it's possible. So what I see is the top expression has y in common, the bottom one has x in common, or the top one I would say a negative y. So if I factor out negative y, it would give me 10 and plus cosecant square x and y. Don't forget the y I factored out is different than the y in parentheses, okay? The bottom one, I can take out an x, and I have 10 left, and I have plus cosecant square x and y, and finally, this big expression is going to get canceled out, so finally my answer is negative y over x. Here you go. So that's my first example. I have one more, kind of quick one. So this is actually practice problem number 72 on page 686. So I have x is equal to secant of 1 over y. Okay, so just like it's different implicit derivative problem, so I'm just going to take derivative both sides. So left side, if I take derivative of x, since it's x term, I don't need any dy over dx. So derivative of x itself going to be 1. Derivative of secant of something, it's going to be secant of that angle and tangent of that angle. See, I don't need any dy dx because right now I'm just taking derivative of the trig function itself. So you need dy dx when you take derivative of the angle, and whenever there's a y, then we need dy over dx. Okay, so since now I will be taking derivative of 1 over y, so you don't have to take derivative of both. You just have to take the angle, whatever that is, doesn't matter which one, is the same thing. Take the derivative. So I'm just going to do that on the side. If I have to take derivative of 1 over y, I would move it to the top, becomes negative 1. How would you take derivative? I would, remember you add 1, oh my bad, you move it to the front, and we take away 1. So if you move it to the front, it's negative 1, and y to the negative 2. Once simplify, it's negative 1 over y to the second. So that's the derivative. That's what I need to multiply this expression by. Negative 1 over y to the second. Since this was my y term, so this is where I need dy over dx. Almost there. Now you just have to solve this equation for dy over dx. So let's just rewrite this first. So this is secant 1 over y, tangent 1 over y, and how about if I multiply together and put y squared here, and there's a negative 1 here. Negative comes from this one here. And at the end, there's dy over dx. I just rewrote the last step. At the end, I need to isolate dy over dx, means I would multiply both sides by the reciprocal of this one, or I would times it by y to the second first and then divide by the top expression, either or. So once I multiply by the reciprocal, so on the other side, this would be y to the second. There would be negative. So it's secant of 1 over y, tangent of 1 over y, and it's equal to dy over dx. And I don't think so there's anything I can do to simplify, and yeah, so that's going to be all, and that's my final answer. So this is pretty much all. Thank you guys. Thank you for watching. Bye-bye.